My name is Zalaziewicz. I'm a geologist. I work at and teach geology at the University of Leicester in England. I'm a general geologist, an all-round geologist, rocks, minerals and fossils, and from them I try and work out aspects of the history of the Earth. Yeah. Okay, I currently chair something called the Anthropocene Working Group, and that is a small part of a subcommission called the Subcommission on Quaternary Stratigraphy that deals with the geology of the Ice Ages, and that in turn is a small part of something called the International Commission on Stratigraphy, which is the body that oversees the geological timescale and how it is set up and defined and used within geology. So the Anthropocene Working Group is looking at the question of whether there is such a thing or can be such a thing formally as an Anthropocene epoch, let's say, and whether therefore one can say that the Holocene epoch within which we formally now live has finished at some time in the past, and whether we are in this new period of time. It's both a historical unit, but also for geologists a material unit. So it is made up materially of all of the strata which will have formed ever since the Anthropocene may be said to have started. So we have to try and work out what the Anthropocene is geologically, work out whether it's real. If it's real, work out whether it's useful to have it as a formal reality, and then if so, how, where and when can we define it? That's really because the geologists are reacting to a suggestion, a proposal made about 14, 15 years ago by Paul Crutzen, who's a very well-known, well-respected Nobel Prize-winning atmospheric chemist, who, together with another scientist, Eugene Sturmer, suggested that the Holocene had finished and that a new phase in Earth history, the Anthropocene, had started. That idea was quickly taken up, particularly after Paul Crutzen himself published it as a single-page paper in Nature in 2002, and the name began to be used in scientific papers very shortly afterwards, as if it was real, as if it was formal, without any sense of irony or joking. And therefore, we as geologists had to respond to it. I became personally involved when the group I was then part of, the Geological Society of London's Stratigraphy Commission, discussed this. It was about 2008. Whether to react to respond, and was there any sense at all in suggesting, proposing a new epoch? Somewhat to my surprise, the majority of these geologists, who are technical, non-radical, non-revolutionary, stratigraphers, geologists working for a variety of universities, oil companies, government bodies, agreed there was merit in the idea and that it should be pursued further. We published that idea in 2008 in a paper in GSA Today, The response was quite large, both positive and negative, but probably largely positive on the whole, from the wider community, and that began to include the humanities communities as well. So we were invited after that to set up the working group, the Anthropocene working group, as part of the formal decision-making structure which looks after the geological timescale. And really that's where we've been since there. You know, the group has grown from its initial half a dozen to about 30 people now, and we are looking at the Anthropocene, what we might take to be the Anthropocene, because the Anthropocene is it's a human construct to try and describe, to explain a set of phenomena which are taking place, which clearly have reality. They're clearly affecting the Earth and its strata. And the question we have is what to do with them. Okay, so to study the Anthropocene means that we have to take changes to the Earth system, and that might be changes to the biology, the air, the oceans, the ice caps, and so on, and convert them into geology. So therefore we can take landscape changes and convert those into what we call lithostratigraphy, you know, the science of strata. So the buildings around us, including the Abattoir, we can consider as part of something we might call the urban stratum. It has a physical reality. It's very distinct as matter, as recognizable matter from natural clays and sands and gravels. It's forming in places, including in Toulouse, a thick layer on the surface of the Earth, which you can regard as a complicated and distinctive stratum. And you can separate that from earlier deposits formed primarily by natural processes. We can take chemical changes. We can take what we might call pollution, you know, whether it's of the soil, of the air, of the waters, and convert that into what we call chemostratigraphy. So chemical changes in layers of sediment accumulating today which will become strata in the future. So let's say we can take the changes to the carbon cycle. Our burning of fossil fuels takes carbon from the ground of a particular composition, particularly isotopic composition of light versus heavy carbon atoms. And that is changing the composition of the carbon that is therefore going into the strata now forming, you know, into plants that will become, let's say, coal in the future, into shells that will become limestone and so forth. And then we can take biological changes. We can changes to the biosphere, which might include such things as extinctions, and also species invasions, which have already had a large impact. We have, more than at any time previously, I think, in the history of the Earth, reshuffled, changed around animals and plants from one continent to another, from one ocean to another. Those are the fossils of their future, and their descendants will become the life of the future. So they're part of chemical changes that are permanent changes that are being made to the Earth and therefore to the strata that form a record of that Earth. So that's broadly the kind of analysis that we're doing. Of those changes, some have already taken place to a large extent. The urban stratum is already well established around the world. You have cities like Shanghai, New York, New Orleans, Paris, London, Amsterdam, and so on, which cover very large areas and in some cases are preservable as fossils into the future. Other changes are barely starting. We have not yet reached a mass extinction event. There is an increase in species extinction, but we're not yet at the level of, let's say, the Cretaceous-Tertiary boundary extinctions, when perhaps 60 or 70% of species became extinct. That is likely within the next few centuries, at current trends. Something else that has not yet happened is climate change. The climate drivers have changed, and changed radically. The rate of change to the carbon dioxide concentration to the atmosphere, over 100 parts per million within not much more than a century, is probably more rapid than any change we know of in Earth history. But the Earth is a big physical body, and so the temperature changes have barely begun, and sea level change has barely begun. Those are likely, much more likely than not, over the next few centuries. And yet we're still, for now, and perhaps, hopefully for the next few decades, within what is essentially a normal interglacial conditions of sea level and temperature. So the Anthropocene is complicated. There are different types of change in different places, operating at different speeds, at different rates, and we have to try and take all of that into account, to integrate it all into our current, if you like, analysis, understanding, description of the Anthropocene. But for sure, one currently has to separate the question of global warming, which almost certainly has begun. You can see that in the high Arctic and the Antarctic, in West Antarctica, in Greenland and so forth. But overall, the likely changes, and the IPCC have probably got the most reasonable estimates of that. When they come, they will intensify the Anthropocene, not least because the changes to the Earth's physical structure and biology will mean the effects of the temperature change will be even larger than they would be, if you like, on a natural, undisturbed set of ecosystems. So one of the questions is when might the Anthropocene be said to begin? And here we have to, I think, make a clear distinction between history and a sequence of historical events which you might judge historically, and geology and the business of defining units of time and of strata, which is very pragmatic. And the main thing with defining a unit of geological time is to have a boundary level that one can trace within strata around the world. And that does not necessarily coincide with the historically most important event or the historical tipping point. For instance, in the boundary between the Ordovician and the Silurian periods, which is about 450 million years ago, which is a time period I work in myself. The boundary is there because of a series of very large-scale Earth changes. There was the inception of a very major short-lived glaciation, the collapse of that glaciation, major extinction events in two pulses, both at the beginning and the end of the glacial phase. There was a major rise of sea level covering the land, and also that sea became stagnant, oxygen starved over much of that time. None of those events are chosen as a boundary level. For purely pragmatic reasons, the origin of a couple of species of planktonic fossil and their appearance in strata in one place in Scotland was chosen because that is regarded as a level that is most easily traced around the world. So it is linked. In fact, it postdates most of the really big major environmental events, but it is, for pragmatic reasons, the boundary level. So again, with the Anthropocene, we have to try and use a similar logic. The Anthropocene, we can say, is different from the Holocene because, not so much because humans are leaving a greater mark, but because the Earth system is beginning to change physically, chemically and biologically. And it just so happens that humans are currently the main driving force of that. Now, one can pick any number of historical tipping points which are important in that. One of these may be the introduction of fire to clear forests, and that happened even before the Holocene, more than 10,000 years ago. One can pick the beginning of agriculture, because that started large-scale changes to landscape, and also enabled large increases in population of humans. That happened from about 8,000 years ago. One can pick, as Paul Crutzen suggested, the beginning of the Industrial Revolution, about 200 or 250 years ago, because that set in train, the rise in energy use, technology, and so forth. The trouble with those events, geologically speaking, stratigraphically speaking, as regards defining time intervals, is that they evolved in time and space. So agriculture started in one place and spread slowly across the world. It's what geologists call diachronous. And the same to a lesser extent with the Industrial Revolution. Started in Britain, moved across to Europe, moved to the United States of America, and then moved to other parts of the world. So over a couple of hundred years, the big industrialization signals that we see in strata are of different ages. The most popular, if you like, or the time interval that's most seriously considered at the moment is the mid-20th century. Not simply because it's another great, what's been called the Great Acceleration by Will Stephan and John McNeill and Paul Crutzen. This great increase in human economic activity and so forth. But because those effects, which included most of the oil burning and therefore most of the chemical changes associated with that, almost all of the plastic that's ever been produced in the world, that is present in much of the strata that we see, almost all of the aluminium we've ever produced. And when something happened, it spread around the world very quickly. It also coincides with the beginning of the nuclear age, when artificial radionuclides, which you can easily detect in sediments, as in us, spread around the world geologically almost instantaneously. So as regards defining a boundary, that currently appears to be the leading candidate for that. Again, historically, one can argue which is the most significant. And of course, historically, all these events from the very beginning were significant. But in terms of geology and practicality, then it looks like the mid-20th century currently seems to work the best. Well, is the Anthropocene the right name? Well, it is a good question, because words, as you know, are important, loaded and treacherous things. There has been criticism of the Anthropocene because of the weight it places upon the Anthropos, the human, the person. Therefore, you can be led into seeing it as a search for humanity and humanity's effects within strata. As a geologist, that is not as important as looking at the way the Earth system is changing, and whether it is humans, or let us imagine even, that rather than humans, but a set of, I don't know, mutant koala bears from Australia had suddenly become very powerful, very strong, very organized, and had started destroying forests and poisoning seas and taking carbon from the ground and burning it. What would our response be? So, I think, and there have certainly been alternatives proposed to the Anthropocene, which may be less biased in favour of the human driver and the human link and the human connection. And one of those is the homogenocene, to reflect the homogenization of the world's animals and plants, via species invasions by being carried by humans. Another possible synonym is the mixocene, the age of slime, by the oceanographer Daniel Pauly, who sees impending warmer oceans, more stratified, less productive, fewer fish, more microbial colonies, more jellyfish, and so on. The trouble is that Anthropocene is here. We're dealing with the fact it has, if you like, beaten its other competitors, partly because the case was so clearly argued by Paul Crutzen, particularly in the one-page proposal in Nature. It was very effective. I think we simply have to live with it. It is, the phenomena is clearly real. The word is a fact on the ground. So we simply have to use it as effectively and as carefully as we can. And probably it is not realistic to think of alternatives right now. It does make us reflect, I think, and that's one of the reasons it has been taken up so much by the humanities, in the realms of philosophy and history, economics, law even, and so forth. For me as a geologist, that's a great thing. I usually work on subjects which are quite obscure, which are of little interest to most of my fellow human beings. So to work on something which is closely related to what I do, to rocks, and to find it of wide interest is great. Not least because some of the reflections that come back at me from my colleagues who do work in the humanities are very, very useful. Not least because as geologists we have to try and understand the driver behind geological forces. Now that humanity is a driver, clearly, and a very major one, we now have to understand humanity and what drives it. And that's a question that geologists are remarkably poorly equipped to deal with, but philosophers, historians, and so on, have struggled with this for decades, and they have insights that will help us explain the geology that is produced. I guess the use of it is it provides the biggest ever context for human activity, human history, human futures, in that you can compare. The Earth is remarkably good at acting as a memory for past events. Strata are remarkably faithful absorbers of information, of the biology, the chemistry and the physics of the Earth. And we can work out a very big and forever increasing, forever enlarging history of the Earth. And part of the use of that will be to help guide us as we go from the nice settled conditions of the Holocene, which has been much like the nice settled conditions of the last 30 or 50 or so previous interglacial phases over the last couple of million years, into the novelty of the future. Because when, and when is much more likely than if, when temperatures increase by 3 or 5 or 6 degrees globally, when sea levels rise by more than a few meters, let's say by 10 or 20 meters, and when all the knock-on effects from that happen, we will be in a new world for us. But in some ways it will resemble some ancient worlds we have in the past. Global warming events are not new in nature. There was one 55 million years ago at the boundary, of what we now call the boundary between the Paleocene and the Eocene epochs, when a couple of thousand million tons of carbon quite naturally went from the ground into the air and the oceans. The world warmed up, the oceans acidified, some animals and plants did very badly and died out, others took advantage and evolved and radiated. The world changed. Another one was similar events happened even further back in the Cretaceous period, and even further back in the Jurassic, and even further back in the Ordovician and Silurian periods where I work. So you can use these narratives of the Earth as we're working them out, which we try and make as far as possible to be consistent with the truth as we see it. We can use these narratives as partial analogues for what is happening now. None of them are perfect, because some of the changes that humans have brought to the Earth are truly novel. There has been nothing like the urban stratum, in the past. Within the urban stratum, there are what we call technofossils. All the objects, the camera and the microphones that are recording me at the moment, one can regard as artifacts made by biological species, that is us. Many creatures produce what we call trace fossils, footprints or burrows or nests. Usually one species makes one or two or three of these. We have made millions of them in very large amounts. And those trace fossils, technofossils as we call them, are evolving in what we call a technostratigraphy far faster than any biology can evolve. That rate of evolution has been intensifying markedly over the last few centuries, and it is accelerating even now. So it is producing, if you like, something that's been also called a new emergent system, an emergent sphere, a technosphere, which is evolving, is sprung from the biosphere, which is linked with the lithosphere, the hydrosphere and the cryosphere, and is creating new processes, new conditions, at an entirely novel speed to the Earth. And it is hard to find any natural analogues for that. But for the other things we do, the mass extinctions, the temperature changes, and so on, we can, to an extent, have an idea of what we are in for. Yes, I mean whether it's geology displacing the idea of humanity, or perhaps simply providing a new prism to look at humanity through is probably better. I guess humans have always thought about their place, their position in nature, and it's been said by a number of people, let's say Dipesh Chakrabarty amongst others, that there has been this idea that nature, the natural world, simply provides a kind of inert, benevolent backcloth to the human story, the human enterprise, the human adventure. Well, what is becoming clear, is that humans are part of nature, and they have become a large part which is modifying, perturbing, changing the natural world sufficiently to create new geology. And so from being, if you like, marginal characters in the Earth story, as it were, at least for the time being, we've become, if we can call ourselves a collective we, have become a force to be reckoned with, to be set, alongside the motion of tectonic plates and the movement of ocean currents and that kind of thing. How that is going to develop, I'm not really sure. I think I'm not really qualified to, to comment on. I suspect, in trying to understand the relationship between humans and the Earth system, I'm as confused as most of the rest of us are. I guess one of the things it does do is it provides, one can look at the geology of the future. And the Anthropocene, if it is here already, if it can be formally said to be here, whatever else it is only just beginning. So it is a little like landing on the Earth 65 million years ago, a few years after the meteorite landed whose effects probably killed off the dinosaurs and much else. So it is providing a new perspective of the future, and I guess there are two futures in there. One is if humans are a temporary phenomenon. That is, we arrive, we make hay, we overreach ourselves, we become extinct. The Earth recovers, has been forced into a new direction, clearly has been forced into a new direction, and then, much as the world did, after the dinosaurs died out, it will evolve a new pattern of life and of physical and chemical patterns. If humans persist, or if some combination of human and technosphere persist, whether it is biological or electronic or mixed force, intelligence, what have you, then of course we're into a completely new realm. That really will be a step change, in the way the world operates. Like the biosphere, we're a means to process large amounts of energy. And we've very quickly, become a major player in that respect. And if that is going to persist, then goodness knows where, it's the science fiction writers who are probably the best leaders for us in that respect. As regards geoengineering, then, well, we already do it. Clearly, we do it. But we do it for our current pragmatic, practical purposes. We cover large areas of ground with concrete and therefore make them less permeable to water. That process has been called terraforming, even by some of my more traditional colleagues in there. To go on from there, then to try and to do geoengineering with a view to modifying, let's say, patterns and balances of temperature and rainfall and such like, on the planet, seems to me quite hopeful. It's a hopeful monster, which might be used as a last resort in the future. Let's say if there is temperature tends to go up and down in jumps. If temperature on Earth jumps by 2 or 3 degrees centigrade, let's say sometime in the next 50 years, that is going to cause dislocation in human communities and difficulties. And then there will be demands to do something, and I suspect geoengineering might come into it. My suspicion, personal suspicion, and I have no expertise in this, is that the Earth system is so complicated and we still understand it so imperfectly that it will probably end in tears in one way or another. And if we manage to alter conditions, let's say, of temperature, then it might be at the expense of making other changes elsewhere, or at not altering some parameters, such as, let's say, ocean acidity, in there. Again, as a completely personal opinion, it seems rather easier to me to try and reduce some of the pressure that humans are currently putting on the Earth, particularly by, burning large amounts of carbon in there. And part of that is maybe simply a question of transferring resources from one set of investments and money-making opportunities to another. But that's a personal view, in a field I am completely inequipped, to hold any, a sensible conversation in. But in terms of geoengineering is here, and we are simply living with the unintended consequences, of what we are doing for other purposes. Okay, well, as regards Anthropocene and governance, again, it's a field in which I have little sensible or measured to say, but there probably is some scope for using it, not least because it tries to integrate changes to the earth and set them against, if you like, a common standard, a common context. One of the members of the Anthropocene Working Group is in fact a lawyer that works on the international law of the sea, Davor Vidas at the Fritjof Nansen Institute, and he's looking at using the Anthropocene as one context, one means of guidance towards evolving the next iteration of the international law of the sea. The logic being that so far all of the versions of the law of the sea have been based upon a stable ocean, a land-ocean system, but changing human institutions. What is clearly happening now is that both human institutions and the land-sea system is changing, and therefore the legal framework will have to adapt to that. That seems to be sensible, and also it offers a little bit of hope in that while human communities do tend to disagree often and sometimes come to blows about things, there is still, if you like, a respect for the rule of law, both nationally and internationally. So if one can use the Anthropocene changes or the ensemble, of characters that we may use to define changes in the oceans, to help with something practical like that, then overall that should be a benefit. It means that we should be able to organize our lives with a little bit more thought and consideration, of the natural geological, if you like, or geologically based world around us. It's a relatively small example, but potentially, again, if it works, then it may be a model for other means of establishing governance. I personally like the Gaia idea because it makes one think. To what extent his various positions, on, the Earth, as superorganism are valid metaphors or even reflections of some underlying truth. I'm not sure, but it's a way of trying to handle both the complexity of the world, and to look for any correspondences within that complexity that might enable you to understand the working of larger parts of the system. I hesitate to say the whole system, but larger parts of the system better. It's comparable. In fact, James Lovelock developed the Gaia hypothesis without being aware that the path had already been trodden in Russia a few decades before by Vladimir Vernadsky, developing his model, his idea of the biosphere, which is also a very fruitful and interesting, much criticized also method or concept or approach. But it seems to me if you treat it with sufficient, caution, it can be useful. And in, again, his analysis of how the world is changing, viewed through the way he looks at the world, being essentially an engineer and, if like, a reductionist, that's where he comes from. It bears thinking about. I quite like some of the things he says. For instance, he says, carbon is a problem, nuclear power is trivial by comparison. Again, looked at from the point of view of a stratigraphic signal to a geologist, currently one would have to agree, with that proposition. And so set within if you like, the Gaian context, which again, I'm not qualified at all to analyze critically, scholarly, rigorously. But I'm glad it's there, as an idea. It also brings across, and this is partly because he's a very good writer, to a large audience, some understanding, of how the Earth operates. Maybe not, again, so much as a system, as a set of interlinked, complex interlocking systems. So that's useful. In many ways, it's a question which a geologist would turn on its head, because as a geologist I live in the past. And I feel that as a very real past. When I walk upon strata, it is like walking on landscapes or sea floors, which we know were present on Earth 1 million or 5 million or 500 million years ago. And there's a whole succession of these which we can build up cinematographically almost, from the myriad evidence, this idea of how much evidence is there for the past. Well, some years ago I played with the idea of seeing how much one can extract from a single pebble of rock. And the answer is an awful lot. A book, it could be a series of volumes indeed, if one put one's mind to it. Thousands of fossils, millions of mineral fragments, at least 10 different geochronometers that tell you about different stages of that rock's formation, which emphasize this idea of solidity of the information, of the reality of the past. And also having that, the scale of that past, and also the ups and downs, the vicissitudes, the catastrophes and the long episodes of more or less stability, within the Earth. And so I guess that is, over the years, has become more and more impressed upon me. So if one then takes the Anthropocene as a geology of the future, and it largely is, whatever we start now, we'll keep rolling on into the future, then I guess, because almost certainly we will see significant changes to the Earth system, involving things like climate, and sea level, and marine chemistry, and biology. And almost certainly that will look to be, within the rock record, it will look to be a very rapid, abrupt change. More rapid than some of the changes we consider catastrophic in the past. And times of change in the past have always been times of uncertainty, if you like, of peril even, for particularly the organisms, biology of the past. And some didn't survive, some thrived, some did very well, and it cleared, if you like, it set in train another version of history, another course of history. That course is unpredictable, in the same way that after the dinosaurs died out, again, if one came back to Earth just after that, one could not predict that these small, squeaky, furry things, the mammals, would take over the position of top predator, both on land and in large parts of the sea. So the future, the far future, will, one way or another, be marked by change immediately, and then maybe it will settle in geological timescales to some future stability. I guess as for us humans, as it said in the film, it'll be a bumpy ride. And we will have to cope with that as best as possible. I'm a human, I worry about that, and the same, for how, my and my friends and my family's children and grandchildren will cope. You hope they will. The world is changing very quickly in many ways, so we hope some of those changes will help them as well as hinder them. It will be, a grand adventure, however, one looks at it. And it will be full of surprises. I mean, I think that's, if anything, both human history and geological history teaches us. Climate history, ocean history, planetary explorations. Around the corner there will be things we haven't thought of that will emerge to be important. So I think we should, I guess, wait for it with our eyes open and be ready to adapt. I suspect we're not very good at doing the sensible things, which is to organize ourselves globally and mitigate the very big changes. We don't have a good track record in that. I hope it will get better, but one suspects, we will have to follow the adventure through to wherever it might lead us.